In this video, which is titled How to Shaders, we'll learn how to approach creating some of the fundamental materials including plastic, parquet or wood generally, concrete, and metal. Let's start with plastics. I'm going to open up the material editor, create a new V-Ray material and assign it to the shader ball. And let's run the IPR as well. Now we are going for a red plastic here. For plastic shaders, diffuse color and SSS color are probably the most important component and contributor to the final look alongside reflection. And normally you want to have the same diffuse and SSS color. So let's me add a new V-Ray color map. And change its color to a vibrant red with the RGB values of 183. 5 and 5, and change the RGB color space to sRGB primaries as we are in ACES, and this map will be used in color inputs. For now, just use it as the diffuse color input. Before doing anything with the reflection, I want to come down to the BRDF section and use roughness instead of glossiness. Now coming up to the reflection section, I mentioned in the reflection video that for most materials and shaders, you can safely keep the reflection color at white to keep the shader as physically accurate as possible. In the past, we used to control reflection color and roughness and then define very specific IR values for each shader. Just forget that. In this new approach, reflection color is almost always just a simple white color, and the IOR value for most daily shaders like plastic, wood, concrete, and so on can be around 1.5. The only thing we are interested in is the reflection roughness. We add variation to the reflection roughness with a grayscale texture, and that adds all the realism that we need. As we are dealing with plastic, let's change the Fresnel reflectivity to around 1.5, 1.55. If you have any issues understanding these parameters, you can refer back to the previous videos where we explained them in detail. So let's start adding variation to the reflection roughness. I'm going to add a V-Ray bitmap node and load this BW_metal texture. And this map will be connected to the reflection roughness. I'm just going to change the color space to raw as we are in ACES, and this is a data input, and connect the map to the reflection roughness input. And this is the result that we get. This isn't exactly what I want. I want to be able to make the bright values of the texture quite darker so we wouldn't get this very rough surface. Probably inverting the texture will result in a better look as well. And as I'm intending to use this map later on as the bump map input as well, I don't want to change the texture itself. I want to keep it at its original state. So let's add an output map after the texture and use the output map as the reflection roughness input. Now enable color map, and first let's invert the values completely. To get a sharper surface, we want to make the texture much darker because remember, our input is reflection roughness, which goes from 0 or black or sharp to 1 or white or rough. So let's grab the first point and change its Y value to around 0.3. And this will make the texture quite darker and the surface quite sharper. Now to avoid very sharp spots, we need to make the very dark values a bit brighter as well. So let's grab the right point and set its Y value to around 0.08. Cool, so that's our shader after adding the variation to reflection roughness. In terms of importance of components for plastic shader or anything similar, now we need to work on the subsurface scattering. So come down to the translucency section and change the mode to SSS. Set the SSS amount to around 0.75. Depending on the particular plastic that you're looking for, the SSS amount can be quite low or high. You need to look at your reference image and see if it has a lot of SSS or not, and then decide on the amount. Now we can use the same red color that we used for the diffuse map as the SSS color and scatter colors as well. And now set the SSS scale to around 10 centimeters. Because we are using a fairly dark color as the scatter radius and the scale is multiplied by the scatter radius color, that's why I used a high scale value like 10 centimeters. And this really adds quite a lot to the overall realism of the shader. It's beautiful. Now, the next thing to consider is to work on the bump mapping. For most surfaces, you need an overall unevenness that can be achieved with a simple noise and then more high frequency detail, which you can just reuse the reflection roughness map. So add a very normal node. Use the original reflection roughness texture as the bump map input. And connect very normal node to the bump input of the shader. And now we need to dial in the exact bump amount that is needed. We can enable real zoom and zoom in to see the results a bit better. Obviously, the bump amount is too much. Let's decrease it to 0.1. Still way too much for a surface like plastic. Let's try 0.01. I think it's still too much. Maybe try 0.003. Okay, that's good. We don't want to exaggerate anything. Subtle and lethal is always better. So that's the high frequency detail. Now we can get out of the real zoom. Let's quickly add that general unevenness to the surface using a noise map. Now, most of the materials and surfaces surrounding us in real life are not made perfectly. They are not going to be perfectly smooth. There is some sort of waviness to them. And if you take a look at any reflective surface around you, you can see that overall waviness, unevenness to them. We can use a composite node with two layers. The first layer would be the roughness texture, and the second layer will be the noise node. And then that composite node will be used as the bump map input for the very normal node. Or we can use very bump material like we learned in the bump mapping video a few lessons back. But the simplest way is to use this existing very normal node and simply connect a noise map as the normal map input. Now let's see if that's possible. So let's add a noise map. Decrease its size to around 5 and let's connect it to the normal map input. Now, the result is odd. We can see the noise pattern, but it looks incorrect. And that is because the normal map input needs a normal texture, not a grayscale texture. Now, is there a way to convert the grayscale noise map to a normal map on the fly? Yes, through a very bump to normal node. So let's add one. And connect the noise map as its bump input. And now connect the V-Ray bump to normal as the normal map input. Now it looks correct. Now that's the type of unevenness that I'm talking about, but we want to be subtle here. So let's set the normal strength to around 0.3 and see what we get. This is a pretty good plastic shader and you can call it a day. One last thing that you can add to your shader to make it more realistic is to make the perpendicular faces a bit sharper compared to the parallel faces the viewing direction. We can do that simply using the coat section of the shader. We talked about this specific topic in the coating lesson a few lessons back. For now, let's set the coating amount to around 0.5 and coat IR to around 1.1. So it will be limited to only the perpendicular faces, and set the roughness to 0.05. And as you notice, this will add another level of realism to the overall shader. We can go ahead and add a bit of variation to the coat roughness, but this is enough for now. The good thing is that this whole shader is being controlled with this one map that is connected to both the reflection roughness and bump input. If you load another texture, you would get an entirely different look. Now let's quickly turn this into a yellow plastic shader. I'm gonna duplicate the original one and assign it. Now we just need to change the color in the Rerecorded node to any color that we want. Let's go for a yellow color with the RGB values of 245, 101, and 5. And that is our yellow plastic shader. Let's pick up the pace a bit and go for a wood parquet shader. So add a new Vary material and assign it. I'm going to add a Vary bitmap node and load this parquet.png texture. And as this is the diffuse color texture and we are in ACES, set the RGB color space to sRGB. I'm going to set the tiling to around 0.75 as well. Now I'd like to use the roughness mode when using Vary material, so let's change the mode to roughness in the BRDF section. Set the reflection color to white, and IOR can remain at the default state as we discussed it earlier. Now let's go for the reflection roughness immediately and load this parquet_roughness texture. Change the color space to raw, as this will be a data input, and tiling to 0.75 like our diffuse color texture. Now, like the previous shader, I'm going to quickly invert the texture as this texture was created for glossiness workflow. Now, if I view the image and zoom in, you'll notice the narrow edge between the boards are black, which if used as the roughness map will end up giving us sharp reflections. And the wood grains are also darker, which again make the surface sharper if used as the roughness textures in those areas. Now, by inverting it, the map will be proper to be used as a roughness map. Now, you can do that in the output rollout of the texture. Now we can connect it directly to the reflection roughness input, or like the plastic shader, let's put it through an output map for further adjustments. So connect the roughness texture to an output map. And connect the output map to the reflection roughness input. I'm just gonna make the dark values a bit brighter by increasing the first point Y value to around 0.1, and that would make the sharp parts less sharp. Now connect this to the reflection roughness, and this will be our shader for now. Now let's quickly add some bump mapping as well. I'm gonna copy the reflection roughness map and load this parquet_bump texture. Just make sure it's not inverted, because if we take a look at the texture, we know for bump maps the black pixels cause indents, and this map looks right at its raw state. And connect it to the bump map input of a very normal map node. And connect that to the bump map input of the Vary material. And let's decrease the bump amount to around 0.25. And finally, let's add that general waviness like the plastic shader. I'm just gonna steal the noise and the bump to normal from one of the plastic shaders and connect the bump to normal to the normal input of the Vary normal node. And set the normal amount to 0.25 or 0.3 like the plastic shader. And finally, let's go for that sharper perpendicular reflections using the coat component. I'm gonna just set the coat amount to 0.3, coat roughness maybe to around 0.1, as I don't want it to be very sharp, and coat IR to around 1.25, so it is limited to only the incidence angles. So that's our parquet shader. Now let's go for a quick concrete shader. I'm gonna add a new Vary material and assign it. Change the mode to roughness in the BRDF section. I'm going to add a new Vary bitmap node. and load this concrete underscore 01 underscore D and use it as the diffuse map. For the reflection roughness map, connect the same map first to an output map. For the same reason that we inverted the parquet roughness texture, we need to invert this map as well and use it as the reflection roughness map. And for the bump map, connect the original diffuse map to the bump map input of a very normal map node. And set the bump amount to something like 0.3. And this will give us a simple concrete shader. I didn't use that noise map here for that overall waviness. You can do that as well if you wanted to, but here the surface is rough, therefore it won't be that visible. And finally, let's go for a metal shader. I'm going to create a new V-Ray material and assign it. Let's use the gold preset to get us started. I'm just gonna make the color a bit less saturated with the RGB values of 243, 207, and 121. For the roughness, let's add a V-Ray bitmap node and load this BW underscore metal underscore 02 texture. Now, for now, let's connect it directly to the reflection roughness to see how it looks. Let's set its RGB color space to raw as it's a data input. Increase the tiling to 1.5 and 1.5 and increase the W angle to 125 to give the scratches a bit of diagonal direction. As always, let's use an output map before connecting the texture to the reflection roughness input. Enable color map, set the Y value for the first point to 0.05 and for the second point to 0.4. I'm just gonna change the point types to Bezier corner and add a bit of bulge to make the values of the map less contrasty. For the bump map, connect the original roughness texture to the bump input of a V-Ray normal node and connect the normal node to the bump input of the V-Ray material and decrease the bump amount to 0.02. And finally, let's steal the unevenness combo from the plastic or the parquet shader and connect it to the normal map input of the normal node and set the normal amount to around 25. And here is our metal shader. Just make sure the noiser is disabled so we can see all the details. It's a nice looking shader. Good for now. So that's how you approach creating different shaders in V-Ray for 3ds Max in their simplest form, obviously. This can get much more complex than this. Now you have a good foundation to build upon. It's a very simple approach. Specular or reflection roughness is the key to everything and you build around it. So in this lesson, we learned how to create shaders like plastic, parquet, concrete, and metals. See you in the next one.